So let's say that we have a function g at x, okay, g at x is equal to x times e to the 2x squared plus 4. And we're asked to find the definite integral, okay? All right, so we're asked to find, okay, from 0 to 1, g at x dx. So if you ever see an interval on the integral sign here, you know it's a definite integral, whereas here, we didn't have any numbers, we didn't have an interval, so we know that this is an indefinite integral. Where here, we know that the question's asking us to find a definite integral. So, how do we find the answer? Well, the process would still be the same, so we're going to use our placeholder method here. So we're going to let this box be equal to the exponent, which is 2x squared, and then the derivative of that exponent with respect to x is equal to 4x. One thing I should do is I should make this look a little bit neater. This is a 2. Okay, that's better. Okay. And so now we can go ahead and evaluate that integral. So the integral from 0 to 1 of x times e to the 2x squared plus 4 dx, okay, we're integrating with respect to x, is equal to x times e to the 2x squared plus the integral, and we're going to put dx here, there's the integral of 4 dx, and this is going to also be from 0 to 1. So now we can go ahead and start simplifying this. So in this particular case here, we can use our placeholder. So from 0 to 1, and we would write x times e to this placeholder here, dx. And of course, what we want is this to be in terms of, this box here, right? So what we're going to do is multiply that by d box by dx. So x times e to this box here times d box by dx. And as you can see here, these dx's, you can visualize them as canceling out. Okay, and you can bring this 4 down as well. And then from this point on, now what we want to do is we can substitute our placeholders in. So x is equal to e to the 2x squared d box by dx is equal to 4x. Okay, now as you can see here, we already have an x. Okay, so if we want to make this 4x, we just multiply by 4. Okay, dx. And of course, we want to cancel out this 4. So we'll multiply this by 1 over 4. Actually, we'll just skip that step and bring it right out here. Okay, times 1 over 4. So as you can see here, this entire term is equal to this term, while this integrand here is also in the form that we want it to be in from all the way up here. Okay, so it's in this form here. So now we're actually ready to integrate. So we're going to bring the 4 down here. And so we get 1 over 4 times e to the, because this is 4x right here. Right, let me just actually write this way. 1 e to the 2x squared times 4x dx. Okay, so now we have a 4x, which is good, plus, bring that down here. And then now we can actually perform the integration. So we have 1 over 4 times e to the 2x squared. And as you can see here, you don't have to worry about this 4x anymore because it's in the right form. So we have that, and then plus the integral, or let me just write this here. This will be from 0 to 1, and then plus this integral here. Okay, so the integral of 4 is just 4x from 0 to 1. And since it's a definite integral, we're not going to have to worry about the plus c part. So here we can plug in our numbers. Okay, so e to the power of 2 times 1 squared is just 2 divided by 4 minus e to the power of 0 times 2. So e to the power of 0 is just going to be 1 plus 4 times 1, which is just 4, minus 4 times 0, which is 0. And then when you punch all that into your calculator, you will get this number approximately 5.60. Okay, and that is your definite integral. That's the answer to this question. So there you have it. That's how you evaluate the integral of an Euler exponential function.